Hello everyone. So today we are going to talk about very interesting problem known as palindrome linked list. Okay, we already know what is palindrome. Okay, and now what is this linked list? Okay, let us see the description and find out what it is given. So given the head of a single linked list, return true if it is a palindrome. Okay, they have given a single linked list. Okay, head of the single linked list, and they are asking whether that linked list is palindrome or not. And what is palindrome? Palindrome is, you can take an example of a string A, B, C, D. Okay, if you reverse A, B, C, D, it will be D, C, B, A. That will not be equal to the original string, which is A, B, C, D. So basically, what palindrome string is, that if you by reversing getting the original string, then it is palindrome string. For the linked list, you can say we have 1, 2, 2, 1. Okay, that is a linked list, single linked list. Now if you reverse this simply linked list, what will be the linked list? It will be 1, 2, 2, 1. Okay, so that will be palindrome basically. Okay, so in this example they have given 1, 2, 2, 1, and it has given the output as true because it is a palindrome. Another example is 1, 2. If you reverse 1, 2, you will be getting 2, 1. That is not a palindrome. So that's why they have given that as false. Now constraints are simple. The number of nodes in the list is in the range from 1 to 10 to the power 5. Okay, and node value can be from 0 to 9. Okay, and could you do it in order of n time and order of 1 space? Okay, so that's the follow-up they have given here. Now let us understand this problem deeply and discuss the solution. Now before discussing the solution, okay, let us talk about the brute force solution. Okay, the brute force solution is very simple. So in this case, what we are going to be seeing is that we have given a linked list. What we can do is we can store that into array. Okay, store that into array. So it will be something like 1, 2, 2, 1. Okay, after storing it to the array. Okay, and what you need to do it afterwards is make a start pointer, make a end pointer. Okay, so this is basically a 2-pointer approach. Okay, and now what you can do is start comparing array of suppose the name is array. Start comparing array of start and array of end. If both are equal, then move inwards from backwards and from front, both direction. If at a position when they are not equal, you can simply return false. Okay, elsewise it can return true. So that is a simple approach. But what is the problem with this approach? The problem is only that we have order of n space as we are storing in a separate array. We want to avoid this thing. Okay, so for that we need to come up with solution in which we can traverse this linked list once and compare both directions. Okay, so that is where our solution comes. Okay, so you can take a pause and try to think upon the solution, and we'll discuss the solution after the pause. Now let us discuss the solution which takes order of 1 space and order of n time complexity. So there are 3 steps. First steps is to find the middle element. Okay, I'll discuss in deep. First let's discuss the steps one by one. First we need to find the middle element. Once you are finding the middle element, we need to reverse the second part. Okay, the basic idea is very simple. Like we can the middle element will be 3. Okay, middle element will be 3 for 1, 2, 3, 1. Then what we are going to be doing? We are going to be reversing this part. Okay, not the middle, but starting from the middle plus 1 element. So we'll be reversing this. So it will be something like this one. Okay, once we are done with that, we can do comparison from here and then comparing here, then comparing here, and then comparing here. Okay, so this we need to do in one traversal. Let us see how we can do in one traversal. It's very simple. First step, first we need we'll start with this one. Okay, that is finding the middle element. Okay, so that is itself a very important question, how we can find a middle element in a linked list in a single traversal. So let us discuss that first. Now let us see how we can find a middle element. So suppose you are given a simple linked list. Okay, we can call that as 1, 2, 3, then again 1, or we can take as 2 here. Okay, and then 1. Okay, let us see how we can find the middle, which is this one. Okay, so that is total number of, there are two cases basically. First is the odd case, odd number of elements, and second one is the even cases. Okay, even means the number of elements are even. So what we can do is simple, it's very simple. We have two pointers, one is start pointer, or we can call that as not start, basically we can call that as slow pointer, and one is fast pointer. Okay, both will be pointing to the starting of the linked list. Now what we can do is we need to check whether this fast is null and fast.next is equals to null or not. Okay, if that is the case, then what we can do, we can increment our fast 2 times. Okay, so fast will jump 2 times, 1 and then here, and fast will be here, and slow will be jumping only 1 position, which means slow will be coming up to this position. So slow will be pointing here after 1 traversal. Okay, then again we'll be checking whether fast is null, it is not null, and fast.next is also not null, which is 2. So we'll be again jumping 2 times. So 1 jump and then 2 jump. So fast will be here. At the same time we'll be jumping slow by 1. Okay, slow jumps only 1 when fast jumps 2. So slow reached here and fast reach here. Now fast will not go again because there is nothing to the towards right, it will stop here. Okay, so that's a simple while loop. So fast slow has been reached here, and slow is our answer, which is nothing but the middle element. Okay, so that's for the odd case. Even case is also same only. We have slow pointer, we have fast pointer. Okay, so slow pointer will again be checking, fast will be jumping 2 times, 1, 2 times, slow will be jumping only 1 time, slow is here, then fast will be jumping 2 times. Okay, 1, 2, it will be pointing to the null. Okay, and slow will be jumping 1 time, which means slow will be reaching up to this position, and it has been reached to null, so it will not be going into any other while loop. So slow will be written here. So this is the middle element. Okay, which is nothing but this 2 element, second. Okay, so that is what the first part of the code is, finding the middle element. Now let us see the second part, which is nothing but the reversing of the linked list. So that's itself another good question. Okay, so let us discuss that. So now let us discuss the reverse part. It's again very simple. Okay, what we can do is first, suppose whenever we are passing this, head will be passed. Okay, head will be passed. So first step will be to create a dummy node. Okay, so we'll be making a dummy node which will be pointing to the null. Okay, so it will be dummy, so it will be pointing to the null. Okay, so that's the first step. Now what's the next step? We'll be making a node which will be pointing to the heads next, because we want to store that. Basically we want to store the information and it should not get lost. Okay, so that's why node will be pointing here. Okay, which is nothing but the head towards the next. Okay, and now afterwards what we'll be doing, we'll be making this head, okay, pointing toward the null, because we want this one to be the last element. So what we'll be doing, we'll be pointing this head will be pointing to the null. Okay, once that is done, we'll not be having this pointing here. Okay, now what we'll be doing, once it is done, we'll be pointing our dummy node towards the head. Okay, we'll be pointing the node towards the head. Okay, it's passing, head is still pointing to that same position, but dummy will be pointing to the same position where head is pointing. So what will be lost here, this track will be lost. Okay, so head will be pointing here. Now after that, what we'll be doing, we'll be updating our node with head. So this head will be pointing to the node. Okay, so this is how it is going to be working here. Let me again tell you how it is working. So this is dummy is pointing to this point, head is pointing to this. Now again, whenever we are going to be starting again, then still head node will be pointing to the heads next. Okay, so node will not be pointing here, node will be pointing here. Okay, so this will be changed, this direction. Okay, similar to this. Okay, now dummy is here. What we'll be doing, the head will be pointing to where the dummy is pointing. So head next will be dummy, heads next will be dummy will be pointing to the where head is pointing, and head will be pointing where node is pointing. Okay, so this is it is doing the stuff and going forward. Basically this is rotating towards left direction. Okay, now node is pointing here, node will be pointing to the next, okay, of head, because head is pointing here in the last traversal. And then what we're doing, dummy will is pointing here, then our head, which is nothing but here, head will be here, so head will be pointing to the dummy. Okay, head will be pointing to the dummy, then our dummy will be pointing towards where head is pointing. Okay, so that is what it is going to be doing, and then last head will be pointing where node is pointing. Okay, so like this it will be start doing the stuff, and at the final it is going to be returning this location, which is nothing but the, you can say anything. Okay, it will be returned here, so this will be head. So in the last case we'll be returning head in the case. Okay, so once we are returning that, we can use this information, okay, wherever we want. Okay, so this will be returned like this: 4, 3, then we'll be having 2, then we'll be having 1, then we'll be having null. Okay, like this it will be something like this. This is nothing but the reverse one, how we are going to be reversing. This is just that. Here it is a small correction, it will not be returning head, because last what is the last value that is going to be updated? It is dummy, so dummy will be pointing last position here. Okay, so we are not going to be returning head, instead we are going to be returning dummy. Okay, so that's a small correction from my side. Okay, now let us discuss the third part, which is nothing but the comparison, and it is simplest of all the three. Now let us discuss the solution here. Okay, so I have just minimized the stuff so it is easier to see. Okay, so here we have this function is palindrome, it is entering with the head part. Okay, so first check is that if our head is null and head dot next equals to null, that means if it is not having anything and if it is having one element, then we are sure that it is going to be palindrome. Okay, so for that what we are doing, we are just returning true. Okay, so that's the first case. Now if it is not that case, which means it has having more than two elements, then we are making 2 pointers, slow pointer and fast pointer. Okay, that is both of them are pointed to the head. Then what this function does, we already discussed fast checking that fast dot next is null or fast dot next equals to null. Okay, so you can also use fast not equals to null and fast dot next equals to null. That will be slightly variation in that, but this is also fine. That fast dot next is null, that is going to be comparing, and then you will be comparing fast dot next is also not null. Okay, so basically you will be getting middle element before one or after one depending upon that condition. Okay, I hope that is clear. Now fast dot next not equals to null and fast dot next not equals to null, if both of the case are true, then what we are going to be doing, we are incrementing our slow pointer by one jump and fast pointer by 2 jumps. Okay, that is what we are doing here. Okay, now then what we are doing, slow dot next will be reverse list of slow dot next. So slow will be at the middle element. Okay, that we already seen that middle element will be the slower one. Then what we are doing, the slower dot next we are passing into this reverse list. Okay, reverse list will be passing over slow dot next, whatever will be the next position. Okay, not 1 2, if suppose there are 5 elements 1 2 3 2 1, we're not passing 3, we'll be passing the 2 1. Okay, so we have passed our 2 here, so this will be returned, this will be calling this function. Let's see what this function does. So reverse list takes the head and see, this is creating a dummy, which I already explained, dummy node. Then we are checking if head not equals to null, then we are doing the stuff like list node, we are creating a node, then it is pointing to the head dot next, then head dot next will be pointing to the dummy, then dummy will be pointing to the head, and head will be updating updated with the value of the node. Okay, so this is just a while loop, and at the end we are returning dummy. We are returning dummy, not the head part. Okay, remember that. So this is just the reverse list function, and this will be called from here, and slow will be updating our slow dot next to the next. What this does, slow equals to slow dot next, is basically give us the starting position of the second part of the linked list. Okay, so suppose it is 1 2 3 2 1, that will be here, which is the head part, and slow dot next will be pointing to the for second part's first one. Okay, so that's the thing. Now again, the last part is just the comparison. It's the one of the simplest part in this code. So it is just that we are comparing that slow should not be equals to null. Okay, if it is not equals to null, then we'll be checking if slow dot value not equals to head dot value. Okay, we are checking the not condition, not true conditions. Whenever we are seeing that it is not matching, we'll be simply returning false. Okay, so that's the idea. So if it is not equal, then we'll be returning false. Otherwise, we'll be updating our slow we'll be updating to the next, and head also will be updating to the next one by one. Okay, and at the end we if it is not getting returned from here, which means it is true. So at the end we'll be simply returning true here. Okay, if it is false, then it will be returned here and the code will be stopping at this position only. Okay, so here we are returning true. So that is the code. Now let us try to submit this. Okay, so this works fine. Okay, the runtime is 6 ms and faster than 71.64 of the Java's online submission. Okay, so I hope that was the fair explanation for the code. Okay, so it already had 2 to 3 questions embedded into this. So if you just try to understand this problem, you'll be able to solve 2 to 3 other problems as well. Thank you for watching. We'll be meeting into the next question.